Hello everyone, and welcome to TechnoBoss. I am MacGyver, and today we, to include me, are going to be learning some basic programming and circuitry based on the Arduino platform. The kit that I'm using is the Artist DIY kit that I found on Amazon for $83. Take note, none of this is sponsored by anybody. Okay, I wanted to learn some of this stuff, and this kit looked like it might actually fit the bill. Lesson 2, Active Buzzer. Okay, so overview. In this lesson, we will learn how to program the Arduino to make an active buzzer sound. Requirements: an Arduino Mega 2560, a USB cable, active buzzer, a 1K ohm resistor, NPN transistor, S8050. The breadboard, and several jumper wires. Alrighty. Principle: a buzzer or beeper is an audio signaling device. As a type of electronic buzzer with integrated structure, which uses DC power supply, are widely used in computers. Okay, a whole bunch of things. Buzzers are categorized as active and passive buzzers. See the following. So these are the buzzers in my kit. One of them is active, one of them is passive. Let's see here. When you place the pins of the buzzer upwards, you can see that the two buzzers are different. Let's see here. The buzzer with the green circuit board exposed is the passive buzzer. Okay, so in the kit that I got, the one with the exposed circuit board is the passive buzzer. If you're following and you got a different kit, double check with that kit which one's passive or active, or if it has both. In this study, we will use the active buzzer. The buzzer will sound as long as you supply power to it. So here we can program the Arduino to output alternator in high and low. A slightly larger circuit is needed to make the buzzer sound. However, the output current of the Arduino's GPIO is weak, so we need a transistor to drive the buzzer. The main function of a transistor is blowing up the voltage or current. Straight up, that sounds like it's supposed to be an explosive. So, considering that we're not dealing with explosives, I have to be understanding that completely wrong. The transistor can also be used to control the circuit conduction or deadline. I understand that a bit more. So it sounds like it's supposed to be like an on-off switch. Let's see here. The transistor is divided into two kinds. One kind is NPN, for instance, the S8050. The other kind is the PNP, which is the S8550. Let's see here. The transistor we use is shown below. Okay, emitter, base, collector. Okay. There are two driving circuits for the buzzer, which is in figure 1 and 2 here. So both circuits, 5-volt constant going to the positive of the buzzer, and a leg of the transistor going to the ground. Whatever pin we're using is going to go to a 1K resistor and then to the transistor. A lot of resistors. Figure 1 is the 8050, which is the NPN, and figure 2 is the 8550, which is the PNP. So I'm thinking of this something similar to a relay. The NPN, I'm guessing, is like a normally open, and when you supply power to the base, it closes the circuit, allowing power to go through it. And the PNP, I am guessing, is the normally closed, and when you supply power to it, it opens the circuit, cutting power. Figure 1, set the Arduino GPIO as a high level. The transistor S8050 will conduct, and then the buzzer will sound. Set the Arduino GPIO as low level. The transistor S8050 will cut off, then the buzzer will stop. So I guessed right. Figure 2, set the Arduino GPIO level to low, the transistor S8550 will conduct and the buzzer will sound. Set the Arduino GPIO as a high level, the transistor S8550 will cut off, then the buzzer will stop. I think I'm starting to understand the transistor pretty good here. Procedure, build the circuit. There's no code. There is no code. It says to program, but it's not giving us a code example. It just goes to summary and gives us this nice little picture of how it also looks when it's all wired up. I think the code is probably going to be just like the one for the LED light. It's probably going to be the same as this. We could probably use the exact same code. Write it out anyways, and instead of saying LED pin, I'll probably say transistor pin. I think that's why they didn't give us a program, is because we're quite literally using the previous code just for a different application. We are going to start putting this together. Here is everything we should need. We have the breadboard, USB cables off scene. We have the active buzzer, and as it says in the stuff, circuit board is not exposed on the bottom. Okay. We have the 1K resistor. We have the S8050 NPN resistor. We got the breadboard and several jumper wires. Let's put this thing together. Alrighty. So let's start with, I guess let's start with the transistor and just getting that down somewhere. These things are really close together. In fact, they're so close together, I don't think there is absolutely, nope. There's no way I can just shove this into the breadboard. So I guess what I'm going to have to do is very carefully take these, do a little spread apart, and then tweak it again to where I kind of have them coming back together just a little bit farther apart. So okay. So I'm guessing let's see here. Should be the emitter. According to the picture that we were looking at, it should be the emitter, the base, and the collector. So this I will just plop onto the board. Okay, ooh, I got spacing pretty good. Okay, so it's going right in. Come on. Come on. Not going right in. Okay, good. I haven't broken anything yet, but I'm working on it. Okay. Oh, sweet. Okay, it's in there. Leave it alone. Okay. So the buzzer. Okay, we got a little positive here. And we'll just place this here on the board. So we have emitter, base, collector, negative, and positive. Okay. Now let's take the resistor. Just bend it so we got two little legs. And remember this being a pain in the butt to put in with the other one. So we'll just, come on, at least make it straight. Come on. And Okay, that side's in. There we go. So far I haven't broken anything, so that's good. Wires. Alrighty. So it's going from, so we're starting with red. We're going to go 5-volt hot. So let's see here. So we got, that's the 3-volt. This is the 5-volt. Okay. Which is fourth one from the end. Because this here, yeah, because voltage in, ground, 5-volt. Okay. And this is just going to go to the positive of the buzzer, which is right there. So let's kind of move these wires out of the way. So we got a black one here. So let's see here. In line with this one, because this is the emitter, and it's going to a ground. Fourth from the end over here is a ground, because all the grounds are connected. So there's like, actually I think there's more than 3, no, there's like 4 or some odd mini grounds, because there's a ground here, 2 grounds here, a ground there, and I wouldn't be surprised if there's another ground. So okay, let's go with an orange. And this is going to go pin 8, which is right here. And it's going to go to one of the sides of the resistor, because resistors don't care about direction. So we'll go here. Then the other side of the resistor, which is here, this needs to then go to the base of the transistor, which was here. Okay. And then the collector of the transistor, which is this one. Come on. What? There. Okay. That is going to go to the negative of the buzzer. Okay. So that should be good right there. Now it's time to start writing the code. Since as far as I can tell, we should be using a code similar to the LED code in the last one, similar as in like the exact same, we're going to come up here to define the variable int, then transistor pin, and they wanted us to use pin 8 equals 8. Okay, 1, I know I'm missing the semicolon, so let's get that on, but I know I'm missing something else. Let's take a look at this other code. No, I'm not missing anything. Okay. Oh, because it's in setup where we identify which pin. Okay, so the variable is 8, and instead of saying 8, okay. So then it's pin mode transistor pin, comma, and this would be output, semicolon. Then it would be digital write. Whoop, nope. digital, right. Okay, and this is where we say the pin, which is transistor pin high, which should be all caps, semicolon, delay 1000, one more zero, semicolon, and digital right, transistor pin low, delay 1000, semicolon. So then this should be the code. This feels like this went a lot faster than last time. That's probably a good sign. Up here, verify. Oh, well, oh, a misspelling. Okay, so let's verify again. Okay, we can plug in our USB. So code's good. That's done. Okay, we verified. I sure hope that buzzer isn't that loud. I guess we'll find out shortly. Upload. Will I get blue smoke? It works. And it's annoying. Okay, so that just shut it off. Good. So thankfully that's not as loud as I was fearing it would be. And it works. Sweet. I'm not that big of a fan of making noise, so I am going to just pop on to the next lesson. If you like what you see, find this video helpful, please like and subscribe, and click on the bell icon to be notified when new videos come out. Thank you for watching, good luck, have fun, and stay curious.